Hello, greetings. Now, for this part of our geology unit, we shall study minerals. Now, everybody, you have to take note that our planet is made up of rocks, which in turn are made up of minerals. Now, in order for something to be classified as a mineral, it must satisfy the following. Now, minerals are, number one, they are naturally occurring. Number two, minerals are inorganic. Number three, minerals have known chemical compositions. Number four, minerals have definite physical properties. And number five, they are solids. Also, in addition to that, minerals are usually, although not always, crystalline. Now, the following are examples of minerals common in most rocks. So we have the following minerals like quartz, feldspar, muscovite or white mica, biotite or black mica, calcite, pyroxene, olivine, amphibole, magnetite, limonite, and other iron oxides, pyrite, and the most controversial mineral of them all is dolomite. Now, what are the common uses of minerals? So, for example, we have aluminum. Aluminum is used as packaging materials in the transport industry. Aluminum is used in the building of automobiles and as building materials. Then we have beryllium. Beryllium is used in the making of gemstones and in fluorescent lighting. Then we have copper. Copper is used in electrical wires, cables, and switches. Then we have feldspar. Feldspar is used in glass making and in ceramics. Then we have iron. Iron is used as building materials. Iron is used in the manufacture of automobiles, in magnets. Now, calcite is used in the manufacture of toothpaste and as construction materials. Now, how do we classify minerals? Now, minerals are classified on the basis of their physical, chemical properties, and crystalline structure. Now, how do we identify minerals based on their physical properties? Now, geologists determine the identity of an unknown mineral by describing its physical properties. And one of these physical properties exhibited by most minerals is habit. Now, habit refers to the overall shape of the mineral. So scientists uses the following terms to describe the overall shape of the mineral, like the term equant. So when you say equant, the mineral has three dimensions about the same length, like a cube or a sphere. Then we have the term elongate, in which the mineral has one direction which is long but the other two are short, like a pencil. Or the term platy, in which the mineral has one dimension which is short while the other two are long, like a sheet of paper. Now, other examples of shape or habit of the mineral includes the following. So we have acicular. When you say acicular, that's long and needle-like. Then I mentioned already equant. Any three perpendicular axes through the crystal are more or less equal, like a cube. Then we have prismatic, common crystal habit. Prismatic crystals are pencil-like. And lastly, we have tabular or book-like. So the mineral exhibits a book-like shape. Alright, so those are the types of habit exhibited by minerals. So when you say habit again, that's the overall shape of the mineral. Now, another physical property exhibited by most minerals is luster. Now, luster refers to the light reflected off the mineral and its overall quality. So, in Tagalog, ang tawag dito ay yung kinang ng mineral. So, minerals can be termed according to the following based on luster. So, we have glassy, opaque, transparent, shiny, or most commonly metallic and non-metallic. And one of the first determinations a geologist must make is whether the mineral is metallic or non-metallic. So that is luster. Again, luster is the way light is reflected from the surface of the mineral. So again, ang tawag dito ay yung kinang ng mineral. This is the way a mineral shines or doesn't shine. Minerals can have metallic or non-metallic luster. So minerals based on luster can be categorized as metallic and non-metallic. So as you could see in the following examples, minerals with metallic luster, they are shiny. Medyo makinang po sila. Unlike those minerals that are non-metallic, they are not shiny. Okay? So that's how we categorize minerals based on their luster as metallic or non-metallic. So everybody, I want you to take a look at the following examples of minerals. So again, when we speak of luster, this is the way a mineral reflects light, or we call this kinang ng mineral. So minerals can be classified based from this as metallic and non-metallic. So metallic minerals, they are shiny in appearance, or makinang yung mineral. They are shiny in appearance, while non-metallic minerals, they exhibit a dull appearance, or hindi po siya makinang. Okay, so that is luster. Luster refers to the amount of light reflected off by a mineral. So we can classify minerals as metallic, that is shiny, or non-metallic, which is dull. Now, another physical property exhibited by most minerals is cleavage. Now, cleavage describes the way a mineral may split apart along various planes, or in thin sections. Cleavage is visible as thin parallel lines across a mineral. Or to put it simply, when we speak of cleavage, cleavage refers to the way a mineral breaks or splits apart with smooth surfaces in certain directions. Now, if a mineral breaks with a rough or jagged surface, we call that a fracture. Now, to help you understand further what cleavage is, so ganito lang yan. Now, pag nag-break, nahati ang isang mineral, then pagkahati natin ay smooth yung surfaces niya in certain directions, ang ibig sabihin yan is yung mineral ay may cleavage. Alright? Now, if the mineral breaks, pag nahati yung mineral na may rough or jagged yung surface niya, wala siyang cleavage. Instead, fracture siya. Okay? So that's the difference between cleavage and fracture. Now, everybody, kindly take a look at the following minerals. Look at number 1. Now, what can you say about number 1? Does number 1 exhibit cleavage or fracture? Or what do you think? Alright, so if your answer is that number 1 exhibits cleavage, then you're correct. Now, look at number 2. Now, does number 2 exhibit cleavage or fracture? Okay, so if your answer is that number 2 exhibits fracture, then you're correct. So I hope everything is clear about cleavage and fracture. So again, everybody look at number 1. That mineral number 1 exhibits cleavage. So when a mineral breaks with smooth surfaces, that mineral exhibits cleavage. Now everybody look at number 2. So number 2 exhibits fracture. So meaning if the mineral splits or breaks, it has rough and jagged surfaces. So again, a fracture is a way a mineral breaks when it doesn't break along cleavage planes, or in short, when a mineral splits, it has rough and jagged surfaces. Like for example, look at quartz. Quartz has what we call a conchoidal fracture. And everybody look at asbestos. Asbestos exhibits a splintery or fibrous fracture. So let us now identify the types of fractures. So first we have what we call conchoidal. So when you say conchoidal fracture, the fracture is a smooth curve and bowl shaped. Okay, another type of fracture is called Hackley. The fracture has sharp, jagged edges. And we have what we call uneven. The fracture is rough and irregular. And we have fibrous. The fracture surface shows fibers or splinters. So everybody look at obsidian. Obsidian exhibits a conchoidal fracture. Look at the smooth curve like that of a bowl in obsidian. Then look at asbestos. Asbestos shows fibers or splinters. So you call it a fibrous fracture. And look at quartz. Quartz exhibits what we call an irregular fracture. Now everybody, let's take a close-up look at obsidian and asbestos. So look at obsidian. So look at the fracture. So the fracture is curved and bowl shaped. Okay, so isn't that amazing that the fracture seen in obsidian is curved and bowl shaped? And everybody look at asbestos. So this is asbestos. So you would see some fibers and splinters in the fracture of asbestos. Okay, so obsidian exhibits a conchoidal fracture while asbestos exhibits a fibrous fracture. Now, another physical property exhibited by most minerals is hardness. Okay, now hardness refers to the scratchability or resistance to being scratched. Harder minerals will scratch softer minerals, and geologists rank minerals according to hardness using the Mohs scale. So everybody, I want you now to take a look at the Mohs hardness scale. So at rank 1, that's talc, and talc is considered the softest of all the minerals. Then we have rank 2.0, that's gypsum. Then 2.5, that's fingernail. So this means that fingernails can scratch gypsum, but gypsum cannot scratch fingernail. Okay, then at 3.0 we have calcite. Then 3.5, that's copper penny. So copper penny can scratch calcite, but not the other way around. Calcite cannot scratch copper penny. Then 4.0, that's fluorite. Then 5.0, that's apatite. 6.5, that's steel knife or blade or glass plate. Okay, then 6.0, that's feldspar, then 7.0 quartz, then 8.0 topaz, then 9.0 that's ruby. So this means that ruby can scratch topaz, but not the other way around. Topaz cannot scratch ruby. And the hardest mineral of them all is number 10.0, that is diamond. Diamond is the hardest known mineral here on earth. So diamond can scratch ruby, but ruby cannot scratch diamond. So that's the principle behind the Mohs hardness scale. Now let's take a look again at the Mohs hardness scale. So at rank 1 we have talc. Talc is considered the softest of all the minerals. Then at rank 2 we have gypsum. Rank 3 is calcite. Rank 4 is fluorite. Rank 5 is apatite together with glass and knife blade. So this means that glass can scratch fluorite, but not the other way around. Then we have rank 6, orthoclase feldspar. Then rank 7 is quartz. So this means that quartz can scratch feldspar, but not the other way around. Then we have rank 8, topaz. Rank 9 is ruby. And the hardest of all the minerals is diamond. Diamond is the hardest mineral on the planet. So hardness is considered by mineralogists in identifying minerals. Now another physical property exhibited by minerals is color. Now color is often used by mineralogists in identifying minerals but should not be relied upon. Why? Because different minerals may exhibit the same color, like for example gold and pyrite. So as you could see in the pictures, real gold is very similar in color to pyrite. So the picture on the left, that's gold, and the one on the right is pyrite. So as you could see, real gold is very similar to pyrite in terms of color. So color is very unreliable in identifying minerals. Now, another physical property exhibited by minerals is streak. Now, streak refers to the color of the powder a mineral leaves after rubbing it on an unglazed porcelain streak plate. So, dito po sa picture, may streak plate na hawakin yung puti na parang tiles. Then, pag kinaskas yung mineral dun sa streak plate, merong may iwan na mark tapos may color yan. So, the color of that mark that the mineral leaves after rubbing it on that streak plate is streak. Now, there are some minerals that exhibit special properties such as magnetism. Now, some minerals are magnetic, like magnetite or lodestone. Now, some minerals also exhibit what we call as effervescence or fizz in dilute acid. So, one example of this is calcite. So, ito pag yung calcite ay nilagay sa isang diluted acid solution, bubula-bula yan or mag-fizz. And also, mineralogists consider the specific gravity like density of minerals such as galena. Galena has a high specific gravity. Now, at this point, let us now examine some minerals with their physical properties, starting with graphite. Now, graphite exhibits a metallic luster, so shiny ang graphite. And in terms of hardness, graphite exhibits hardness between 1 and 2. So medyo malambot po ang graphite. Graphite also exhibits cleavage. And in terms of color, graphite is silver to grayish in coloration. Other characteristics of graphite includes the following. So graphite exhibits a black streak and greasy feel. And in terms of uses, graphite is used in making pencils and lubricants. Okay, so another example is galena. Now, galena exhibits a metallic luster, and in terms of hardness, galena has a hardness of 2.5, so medyo malambot din yan. And galena also exhibits cleavage. And in terms of color, galena exhibits a metallic silver coloration. And other characteristics includes the following. Galena exhibits a gray-black streak, is dense, and uses of galena is used as ore of lead. Then we have talc. Talc exhibits a non-metallic luster, so dull yung color niya. Hardness is 1, so malambot yan. In fact, talc is the softest of all the minerals. Talc exhibits cleavage, color white to green, greasy feel, and talc is used in making talcum powder and soapstone. Okay, then we have halite. Halite has a non-metallic luster. Hardness is 2.5, exhibits cleavage, color colorless to white, has cubic cleavage, salty taste, and halite is used as a food additive and it melts ice. And this is the most controversial mineral of them all, is dolomite. Dolomite is a carbonate mineral composed of calcium magnesium carbonate. And dolomite is a term used for sedimentary rock which is formed from such a mineral.
Hi everyone. In this video, we're going to be talking about minerals. So let's get started. What are minerals anyway? Well, in the simplest sense of the term, minerals are the building blocks of rocks. Here's a rock. This is a piece of the igneous rock called granite. If you look carefully at this chunk of granite, you'll see all sorts of speckles of gray and white and black. And if you zoom in, you'll see that these are actually crystals, mineral crystals. This particular piece of granite has the mineral quartz, biotite mica, and plagioclase feldspar. We'll study these in more detail later on. So, on Earth, there are over 2,000 varieties of minerals, some of which are seen here. As you can tell, they come in a wide variety of colors, shapes, sizes, textures, and all sorts of different physical characteristics. Minerals have quite a few uses in our everyday life. Just to give you an example, this here is a rough, uncut diamond. Of course, we use diamonds for jewelry. We also use diamonds in construction applications, as the tips of saw blades, and a variety of other industrial uses. Here's another mineral. This is called fluorite, most famous for its inclusion in toothpaste. Yes, when you see the name fluoride on a toothpaste, that means it's made out of the mineral fluorite. But what else are minerals used for? Well, this here is talc. Talc is a very common mineral that is ground into a fine powder. It's very soft, and it's used in baby powder. Sometimes you might hear it referred to as talcum powder. One more example. This is a mineral selenite gypsum, which is used all around us in drywall. This is the material that's used to build the walls inside modern houses and buildings. But what exactly makes a mineral a mineral? Well, to be considered a mineral, the substance must meet 5 criteria. Let's go through those 5 criteria right now. Number 1, the substance must exist as a solid under normal conditions on Earth. This means if you have a liquid or a gas, under normal conditions, it cannot be considered a mineral. It must be in the solid state. Number 2, the substance must be naturally occurring on Earth. This means it cannot be man-made. So for example, plastic is not considered a mineral because it doesn't exist naturally. It's created by humans. Must be naturally occurring. Number 3, the substance must be inorganic, meaning not coming from living or made of living things. So if you talk about, tree branches or leaves, they cannot be considered minerals because they are organic. That is, they came from living organisms. Another example would be coral. Coral is made by small sea creatures, and therefore it's organic material and cannot be considered a mineral. Minerals must be inorganic. Number 4, the substance must have a fixed chemical formula, meaning it's made up of a specific combination of elements. Let me give you an example. The mineral quartz is composed of silicon and oxygen bonded together, specifically one silicon bonded to 2 oxygen atoms. All quartz is made of this chemical formula. Another example, pyrite, often known as fool's gold, has a chemical formula of Fe, which is iron, and S, which is sulfur. And when these are bonded together in this particular arrangement, you get pyrite. So criteria 4 is that the substance must have a specific or fixed chemical formula. It has to be made of a specific recipe, if you will, of elements. And then finally, criteria number 5. The atoms that make up the substance must be arranged in an orderly crystal structure, a specific structure. Let me give you an example of this. The majority of the minerals that exist on Earth's surface are considered silicates, and that means they're made up of, in part, silicon and oxygen. The silica tetrahedra is the most common arrangement of silicon and oxygen atoms within a mineral. It looks something like this model here, where the red balls of clay represent oxygen atoms and the gray is a silicon atom. And you can see they're bound together in this tetrahedra shape, and this becomes the most common building block of minerals on Earth. So that's what we mean when we say the atoms must be made up of a specific orderly structure. I'll give you another example of that in just a minute. So let's test ourselves a little bit. Here are those 5 criteria. Must be solid, naturally occurring, inorganic, have a fixed chemical formula, and a specific atomic arrangement. So, what about this pool of liquid mercury? Can this be considered a mineral? Well, if you look at criteria number 1, it says it must be a solid, and this clearly is a liquid, so sorry mercury, you're not a mineral. What about this chunk of bituminous coal? Well, if you know anything about coal, you would know that it's actually formed from ancient tropical plants that have been compressed and squeezed together for millions of years. So it is a solid, and it's certainly naturally occurring, but because it's made from plants, it is organic, and therefore it doesn't meet criteria number 3. And so coal is not considered a mineral. Well, what about ice? This is an interesting one. Let's go through our criteria. Is ice solid? Yes. And it does exist as a solid on at least some parts of the Earth, the poles specifically, and high up in mountains, you get water that exists naturally as a solid. So that's fine. Is it naturally occurring? Of course. There's quite a bit of ice naturally existing on Earth. It is not an organic material. It is not living. It never was living, and is not made by living things. It does have a fixed chemical formula, H2O, and it does have a specific atomic arrangement. So is it a mineral? Well, according to our criteria, yes, it is. However, there's a lot of debate about this, and some people think ice should not be considered it because most places on Earth it would exist as a liquid. So we'll give that one a question mark. What about this substance? This is sulfur. As you can see, sulfur exists as a solid. That's good. It's naturally occurring. It forms along volcanoes. It is inorganic. It's not living, and it never was living. It has a specific chemical formula. It's composed of the element sulfur. And it has a very specific atomic arrangement. If we could zoom in, we would see the atoms arranged in a specific way. So, for our criteria to be met, sulfur works. So, it is considered a mineral. Now, let's move on. I want you to keep in mind that all of the physical properties of a mineral, and what I mean by that is the colors, the shapes, the textures, the smells and the tastes, the appearance, the hardness, the sheen, All of these physical characteristics of minerals result from one specific thing, and that is the internal arrangement of the atoms. To give you an example, that sulfur we were just looking at is yellow. The reason it appears yellow is because of how the sulfur atoms are arranged inside. Quartz sometimes appear clear, and that's because of how the atoms are arranged. The mineral halite tastes salty because of how the atoms are arranged. The mineral sulfur, again, has kind of a rotten egg smell, and that's a result of the internal arrangement of atoms. So all of the physical properties result from how those atoms are arranged. Let me give you one really neat example of this. This is a diamond, the hardest mineral that exists on Earth. Fairly rare in nice, complete crystals. It is the hardest substance. It has a hardness of 10 on something called the Mohs Hardness Scale, which we will learn about. Now, diamond is composed of one element, and that is carbon. If you could zoom down inside this diamond, you would see the carbon atoms arranged in a pattern like this. Notice how all the atoms are interlocking, connected to one another. This creates a really strong bond, which is what makes diamond such a hard mineral. But let's look at a different mineral. Did you ever wonder what made a pencil write? Well, a lot of people have the misconception that it's lead. It's actually not lead. It's a mineral known as graphite. Interestingly enough, graphite, like diamond, is made up of only carbon. But if you look at how the carbon atoms are arranged, they're arranged into these sheets, which are not very well connected. The result is that though it's made of the same elements as diamond, it's a much, much softer, weaker mineral. So again, what gives these minerals their physical characteristics is how the atoms are arranged inside. So let's do a quick recap. First thing we talked about was how minerals are the building blocks of rocks, how they have lots and lots of uses on Earth. To be considered a mineral, it must meet our 5 criteria. It must be a solid, it must be naturally occurring, it must be inorganic, it must have a specific composition, and finally, it must have a definite structure. Thanks for listening.